The sun is not on fire. What? But look at that. That looks like fire. It does look like fire. But think about the fire triangle. The sun has the heat, and plenty of it, and the fuel. But it has no oxygen. The answer as to why the sun looks like this is nuclear fusion, the process through which stars produce their energy. Nuclear refers to any process with atomic nuclei. Remember that the nucleus has protons and neutrons, and the atom has electrons on the outside. Fusion refers to the merging of two or more elements. So, nuclear fusion, the merging or fusion of two atomic nuclei. Nuclear fusion is when lighter atomic nuclei fuse together to become heavier nuclei. First, let's understand why this process is able to happen. As we know, the sun is very hot. So hot, in fact, that the atoms get stripped of their electrons. This results in a hot stream of particles called plasma, where we have electrons, neutrons, and protons floating around. In order for nuclear fusion to happen, the nuclei need to fuse together. But there's actually a big problem, the Coulomb barrier. Since the protons are positively charged, they'll automatically be repelled from each other. The same thing happens with these magnets. Just like protons are positively charged, these magnets have like poles. No matter how hard I push them together, they won't stick to each other. In order to overcome this repulsion, you need a pretty big force. Lucky for us, we're inside the core of a star. First, the sun is very massive. The more massive an object is, the more gravity it has, meaning the greater force it has. Second, remember how we talked about the sun's temperature? That matters too. The higher temperatures essentially mean that the particles are moving faster. If they're moving faster, it's easier for them to hit each other and combine. Because of these extreme conditions, nuclei are able to overcome the Coulomb's barrier and finally fuse. Basic hydrogen fusion is when 4 hydrogen protons will fuse through a series of reactions to become 1 helium and some other subs. This is what the overall reaction will look like. Something very important about this reaction is that the product actually has a tiny little bit less of mass than its reactants, somewhere around 0.7%. Wait a minute! Wouldn't the Violet Lavoisier's law of conservation of matter? Well, apparently yes, but actually no. Let's call our friend Einstein to help us out. Take a look at my iconic equation, E is equal to mc squared. It proposes that energy and mass are equivalent. So the mass that is lost actually becomes energy. Thanks, Einstein. Exactly. In this equation, c is the speed of light. So if mass is moving at that speed squared, it's moving at an insanely fast speed. So even the smallest amount of mass can generate the greatest amount of energy. You can think about this using kinetic energy, the energy of motion. When my dog is sitting still, she has no energy. But if she starts moving at a certain speed, that will give her kinetic energy. If she moves at the speed of light, she'll have a lot of energy. With its giant energy output, this is how nuclear fusion is able to power our sun. Next time you look at the sun and think it's fire, consider this. It's actually just a bunch of hydrogen isotopes fusing and releasing energy.